Continuing on with our solving by square roots guided notes, I want to point out the directions for example 2 because we're going to slightly amend these. Determine if each equation can be solved by taking square roots, and then it says or factoring. This is a very important algebra skill that we're not going to focus on. For the purpose of this summer school class, we are just going to exclusively want you to be confident and capable of solving by taking square roots. So if we have to factor, we're going to note that, and we're just going to move on. So we will solve the equations that we can. We'll leave things in simplest radical form if we're not getting nice integers, but we will not be factoring. So I'll point out the ones that we run into that issue. Starting with this first one, we're not going to have that issue. This looks a lot like the ones that we were doing on example 1. So we are still going to try and get the squared term on its own. I'm still going to start by adding that 36 because I would like x by itself. So when you add 36 to both sides, 0 plus 36 is 36. Then I need to move that 3. That is not addition. There's no plus sign. That's multiplication. The opposite of multiplication is division. So I'm getting x squared on the left and 10 on the right. That's not 10. I just realized that my screen... Sorry. I just realized that when I had written out my 36, my computer had changed it on me. So that should be a 6 here, not a 0. 36 that I'm dividing by 3 and getting 12. So now I need to solve by square roots. Now I need to say, let's knock out that squared by square rooting. 12 is not a perfect square, so let's see if we can find any pairs in it. And since we do have a pair of 2's, this will simplify. So I will have under the radical, instead of 12, that's the same thing as 2 times 2 times 3. Pairs make perfect squares. The square root of 4 is actually a regular 2. And the square root of 3 is some decimal, so I'll just leave it as square root of 3. And you'll notice I left a gap because every time you solve by, almost every time you solve by square roots, you're going to get 2 solutions, both a positive and a negative. When we look at part B, a little different, because yes, there's a quadratic term, there's a squared, but I also have a linear term. I also have a constant term. None of those are like each other. There's not another squared to combine with. There's not another plain x. There's no other numbers. Those are all different. Because those are all different terms, this one should be solved by factoring, which again, we will not be covering during summer school. So because this is solved by factoring, it is something that is important to know how to do. It is solvable. We're just not going to do it. So we're going to skip that one. So I'm going to jump to this one instead, which looks similar until we pay attention to, unlike the last one, there are like terms in this problem. So yes, there's a quadratic term, there's a linear term, and there's a constant term, but there's also another linear term. These ones are like terms. They can be combined, so that's what I'm going to do first. So I see a plus 2x, I'm going to minus 2x. They're gone. So I'm left with an x squared, I'm left with a minus 8, and I still have to have an equal sign. Don't forget that that stays there. It's just that there's nothing on the other side, so I'll put it equal to 0. When you solve by square roots, you need the squared item on its own. So I'm going to move that minus 8 by adding 8 to both sides. So there's still an x squared on the left side of the equal sign. Now there's a positive 8 on the right side of the equal sign. Sorry, sometimes that program's annoying. Anyway, we have an x squared equals 8. Since the squared term's on its own, we can solve by taking square roots. That's not a perfect square, so I'm going to go look for some pairs within my prime numbers. I'm going to break it apart. So I will have 2 solutions, positive and negative, but instead of the square root of 8, I will have 2 times 2 times 2, and pairs make perfect squares. So my final solution should be plus or minus 2 square root 2. And let's go and look at part D while I'm here, and then we'll pause it for the next video. When I look at this one, again, squared term, linear term, constant term and another constant, the plain old regular numbers. So for this one, it is possible to combine our two constant terms. However, these two will never, should never be combined. Because of that, you can't solve by square roots. Solve by square roots is exclusively used when there's no other x's other than the squared item. So if you can knock out those linear terms, you can solve by square roots. Here, I can't knock that linear term out. This really is the problem here. So because that doesn't go away, this should be something that we talk about in Algebra 1. This should be something you talk about in Algebra 2. It is not something we're going to talk about during summer school. And I'm writing the wrong thing. This should be a solve by factoring problem. Which technically, oh, that's not true. How many have I done already? I'm trying to figure out how long, these notes are long enough. I'll pause and pick up on the next notes video on party